sometimes we really want to just store a couple different things together in our code, and they're of different types. And we just really want them to, well, be together, or just like return two different types. And that's where tuples can come in. So let's take a look at what tuples are and like how we can like use them. So to begin with, let's just create a tuple here. So let maybe it can be like dimensions. So dimensions equals. We normally want something like an X and Y. So like normally an array might work, but let's use a tuple here. So tuple, and we'll just say maybe it's like 100.0 and 100.0. It's a nice square. And we see here that Rust Analyzer sees this as a tuple of F64, F64. And this is where it gets really interesting because it actually sees them as individually different types. If I change this to 100, it can be an F64 I32. This allows us to have two different types into one little container, which is really, really, really cool and very handy when it's necessary. And we don't want to create like a struct that can hold different like named values. We want this thing. Now, if I did have a struct and it's stored in a tuple of this thing, it would require like, it would require this information to be consistent, but that's structs. They require that. When we're just creating ad hoc tuples like this, here we go. We're just storing data and it doesn't really care what the type is as long as we're consistent. Okay, so we can store that away in here. I can even have something like that prints this out and takes in what this tuple is. So let's bring this back to like .0 here. We're gonna take a function like maybe print dimensions. And we're gonna take in what these dimensions are. So dimensions, and you're gonna be a tuple. So these parentheses with F, I'm just gonna say F32, F32. And I'm not gonna return anything. We're just gonna debug out. So debug dimensions. And here we're gonna call that. So print dimensions and pass in dimensions. Oh, come on. Dimensions. There we go. Now, notice when I'm doing that, the type system automatically changed that over. By default, anything that looks like an F something, so like F32, F64, is going to be an F64 by default, at least on Windows. Over here, I set this to be F32s. It now knows they have to be F32s. Okay, so this should run. We run this. We can now print out this tuple and we see it represented here in text. What if I want to extract just one of them out? If I want to print like one of these, let's make it 100, 150 so we can see the difference. If I want to debug just the first one, so the 100, I can get access to it, but it's not quite like an array where I can do like square brackets with 0. I access it through dot notation. So I'm going to use .0. If I hit save and we run this test, we're now going to see this first one accessed here. So it's a little bit different than normally how it works with like an array, or it feels more like a struct, which is really interesting and really it can also be a little bit disconcerting. That being said, let's say we don't even want to have to do this dot notation out. We just want everything to be out separately. Well, there is a way to do destructuring here. So in print dimensions, what I can do is I can just remove this word dimensions and we can just say, well, this is X and Y. And your type here is this F32, F32. And now we're going to print out X, and we can debug Y here separately. So if I do that, Let's go ahead and run you again. And here is that X, and here's the Y separately printed out. So tuples are very easy to destructure out into whatever you want. Now the order of this is important. We can never flip out. Like this one, this F32 is always going to go into the first item here, and this is going to always go into here. And if I try to destructure just the first item here, it's not going to work because, well, what about this second thing? We're trying to destructure and we can't. So if I try to use this, it's not really destructuring. X is just the full tuple. So if I don't care about anything else, I have to handle that. I have to have something for these values to go into, even if I'm never going to actually use them. This is, for example, perfectly valid here. Anyways, tuples are very useful when absolutely necessary. That being said, I wouldn't pull them out for everything. I would still use structs for most of my data that is going to be complicated, but sometimes tuples in a struct can be very helpful. And with especially with that destructuring out, so we can just sort of easily grab things around here and there. But if you find yourself putting like a whole bunch of things into a tuple until you have like a very large tuple, then I would probably reach for a different data structure. Anyways, hope that you enjoyed this, and I'll see you in the next video. Bye.